Hi, this will be Chemistry CA Week 7. Which of the following mixtures can be separated using filtration? فاحنا we know filtration is used when we have an insoluble solid and a liquid. Oil and water, these two are liquids that can be dissolved in each other. Salt dissolves in water, so we don't use filtration. Sand and water, sand doesn't dissolve in water, so we use filtration for this one. And sand and iron fillings, it's both solids, so we don't use filtration. Which of the following is an ion? Select all that applies. An ion is an atom or a molecule carrying a charge, that's it. Like Cl minus or something like that. An atom carrying a charge, yeah. An electron, no, that's part of an atom. A molecule carrying a charge, yes. A neutral compound, no, it has to carry a charge, either negative or positive. What is a saturated solution? Saturated solutions is when you have a solution that has the maximum amount of solute dissolved in it, that it has so much solute you can't dissolve anymore, or you can even see a bit of solute at the bottom of it. A solution in which the maximum amount of solute is dissolved in a fixed amount of solvent at a certain temperature. Yeah, that's a saturated solution. A solution in which an excess of solute is dissolved in a fixed amount of solvent at a certain temperature. Here they said an excess of solute. لا, احنا we want the maximum amount. A solution in which 1 mole of solute is dissolved in 1 liter of solution at a certain temperature. No, because maybe 1 liter of certain solvents can take more than more than 1 mole of solute, or 1 mole, يعني you know. A solution in which the solvent can dissolve more solute. No, we need the maximum amount that you can't dissolve in it anymore. The separation technique used to separate two solids based on their difference in solubility is selective solubility. Basically, for example, if you have salt and sugar, you put ethanol so that the sugar dissolves, not the salt. That's selective solubility. A beaker containing an ethanol solution should never be heated using a Bunsen burner. احنا we said last week كمان إنه a beaker containing an ethanol solution should not be exposed to any flame, any kind of flame. Only an electric heater or a water bath. Also, we said before that sublimation is when a solid goes into the gaseous state على طول without going into the liquid. A substance sublimes when it passes directly from the solid to the gaseous state upon heating. Check the mixtures that can be separated by distillation. Pure water from seawater, yes, it can be separated by distillation. We'll have the pure water as a distillate, and the salt remaining over. Sugar from salt and sugar. No, you can't separate two solids by distillation. Sand from sand and salt, also two solids, but you can't separate it using distillation. Water from sugar water solution, you can separate the water from sugar. Yeah, you need two liquids with far away boiling points, two different materials, I mean. A mixture of water and ethanol can be separated by fractional distillation. Fractional distillation is you use it when you have two liquids with almost the same boiling points. Like water and ethanol, water is like 100 and ethanol is 78, I think. Which of the following techniques is used to separate black ink into components? We can't use distillation this is distillation, we can't use it to separate black ink, or we can't use filtration either, because filtration is insoluble solid and liquid. Or fractional distillation is for two liquids of boiling points. So we use paper chromatography. Select the picture that represents a technique used to separate the components of a solution of salt and water. For salt of water, like the question before, we use distillation in it, not filtration, because the salt dissolves in the water. Or paper chromatography. That's distillation. Which of the following parts is the fractionating column? See the fractionating column, you'll see it on top of the round bottomed flask. It will be a long tube with little dots inside. These are obstacles, and it's only cooled by air, no water in it. Which of the following is true about fractionating columns? It is used to perform simple distillation. No, it's used for fractional distillation and only fractional distillation. It is a long vertical tube containing obstacles and cooled only by air. Yeah, as we said, it doesn't have any water in it. It's just cooled by air. It is an apparatus that uses water to cool vapors and condense them. No, it doesn't use water. Copper sulfate can be separated from its solution by crystallization. You need to memorize this. Copper sulfate is by crystallization. CaCl2 dissolves in water to form a solution that conducts electricity. When it dissolves into water, it splits into ions, and these ions can conduct electricity. Sugar, on the other hand, is a molecular solid, but when it dissolves, it produces molecules, not ions, that can't conduct electricity. Yeah, this is because unlike sugar, when CaCl2 dissolves into water, it forms charged ions that allow the electric current to flow. What is the molar concentration of 1.0 decimeter cubed solution in which 0.50 moles of sodium carbonate and A2CO3 is dissolved? Here they need the answer to two significant figures. Here they gave us the volume and they gave us the moles. We took the equation as C equals N over V, N being the moles and V being the volume. See the moles is they gave us 0.5 and the concentration is 1.0. If we put it into the calc, we get 1 over 2 or 0.5. Here they said they wanted two significant figures, so we add a 0 at the end. How many moles of sodium carbonate should be dissolved in 0.10 decimeter cubed of water to make 0.5 molarity solution of that salt? Here they gave us the volume and they gave us the molarity. They want the moles of the sodium carbonate. We still use C equals N over V, and they gave us the concentration 0.5. They want the moles N, and they gave us the volume 0.10. If we cross multiply, 0.5 times 0.10 equals N. We put it into the calculator, we get 0.05, and they wanted two significant figures, so we add 0.050. We add a 0 at the end to make it two significant figures. Here they said a student wants to prepare 100.0 centimeter cubed of 0.100 molarity sodium carbonate solution. Find the mass of sodium carbonate required to prepare the solution. But we have the equation C equals N over V. Here they gave us the concentration 0.1 and they gave us the volume 100 centimeter cubed. Here the volume is in decimeter. In the equation the volume is in decimeter cubed. But to convert from centimeter cubed to decimeter cubed, we need to divide by 1000. 100 divided by 1000 is 0.1, and we want to find the moles to find the mass, so we put x. 0.1 times 0.1 equals x or n. We put it into the calculator. You get x or n is 0.01. So we found the moles, and we know the other equation, n over m times capital M. M being the mass and M being the, sorry, it's the wrong equation. M over M. M being the, small m being the mass, and big M being the molar mass. We need to change the equation into m equals nm. We have m and we got the moles 0.01 times the molar mass. We want carbonate solution, they gave it to us. The equation is Na2CO3. N A2 2Na 23 times 2 plus CO3 C is 12 and O is 3 3 times 12 46 plus 12 plus 48, you get 106. 106 times 0.01, you get 1.06. And do you need a calculator for this exam? Without it, if you want to finish in time, you need a calculator. If you don't, يعني خلاص. We got the M 1.06. They wanted to do 3 significant figures, and we have 3 significant figures already. Here, consider the following unbalanced equation. We have CH4 plus XO2 produces YCO2 plus ZH2O. They want us to balance it to get X, Y, and Z. To balance it, we have CH4. We write how many atoms we have. We have C1, H4, and O2. Here we have C is 1, O is 2, and H is 2, O is 2 plus 1. Here we start with, you leave hydrogen and oxygen to the end. We start with carbon. It's already balanced, 1 carbon, 1 carbon. Then you go into hydrogen. We have 4 hydrogen here, 2 hydrogen here, we add a 2. Now it's 4 hydrogen and 4 hydrogen here. Now the hydrogen is balanced. We go back and check for the C. 1C, 1C, C is still balanced. We go to O. We have 2 here, and now we have 2 here and 2 here. That's 2 plus 2. You put 2 here to balance it. Now we have O4 here and O is 4 here. Now your equation is balanced, and Y, since there's no coefficient, you put 1. We get the X is 2, Y is 1, and Z is 2. In this one, they want us to give the ratio by moles, ratio by mass, and ratio by volume. And if the answer is negligible, we put the dash or null. We have CH4 gas plus XO2. We got the X is 2, Y is 1, and Z is 2. CH4 gas plus 2O2 gas, it produces 1 CO2 plus 2 H2O. Here they want 1 mole. We have 1 mole of CH4, 2 moles of O2, 1 mole of CO2, and 2 moles of 2H2O of H2O. وبعدين they want ratio by mass. To get the mass, we first need the molar mass times to get the mass in an equation, you get the molar mass times coefficient. C is 12, O is 16, and H is 1. First we have CH4, C is 12, C is 12 plus 4 times a coefficient. There is no coefficient, we just put 1, so we get 16. They want 3 significant figures, don't forget to put the zeros. For 16.0. O2, we have O16 for 2, 16. You get 32. You multiply that by 2 coefficient, you get 64. We put 0.0 because they want 3 significant figures. 1 CO2, C is 12, O is 16, and we have two atoms of O, for 216. We get 32 plus 12, 44, no coefficient for 1, and you add 1 0 for significant figures. With 2H2O, we have 2 1 علشان ال H, 2 atoms of H and 1, and each one has a molar mass of 1, plus O is 16, you get 218 and 36.0 علشان significant figures. Now you want it in volume. At STP, we know at STP the 1 mole takes up 22.4 decimeter cubed. Here we already have the ratio by mole. 1 times 22.4 is equal to 22.4, and it's already 3 significant figures. 2 moles of O2 times 22.4, you get 44.8, and it's already 3 significant figures. 1 times 22.4, you get 22.4, 3 significant figures. As we said, 3 significant figures. Then we have 2H2O, but be careful here, 2H2O is liquid. Liquid, their volumes are negligible. We only get the volume if it's gas. Liquid, it's negligible, so we put the dash. Now at STP, 2 moles of CH4 combine with blank 18 blank decimeter cubed of O2. Here they want us to do RRGR. I already put the equation here. We have 2 moles of CH4, RRGR. GR, they give us that we have 2 moles of CH4, and they want the volume of O2. X, the volume of 2O2 here is 40. The volume of O2 here is 44.8 علشان 2 moles times 22.4, and here it's 1 mole. 1 times X and 2 times 44.8 to 44.8, you get 89.6, and they have 3 significant figures. You put it into the calculator, you get 89.6. With part B, air is 20% oxygen, so at STP, 2 moles of CH4 combined with the volume of air. We get the air is V air equals VO2 times 5. VO2 here is 89.6. They want it with 2 moles of CH4 times 5. You put it to your calculator, you get 448. 3 significant figures, so you put it as it is. Iron Fe burns to form a black solid Fe3O4. Can a 5.6 grams piece of iron burn completely to form Fe3O4 in a vessel containing 1.12 decimeter cubed of O2 at STP conditions? فاحنا we know when they give us two values, we do RRGR. Limiting excess. We write the balanced equation. Fe plus O2 gives Fe3O4. We balance the equation. Fe is 1, O is 2, Fe is 3, O is 4. So we can put 3 Fe plus 2 O2. Now Fe is 3, O is 4, and it's balanced. Now we have the balance equation. We do RRGR to find the limiting excess. RRGR, they give us 5.6 grams of iron and 1.12 decimeter cubed of O2. At STP conditions, we know that STP is 22.4 and they give it to us. We have 2 moles, 22.4 times 2 is 44.8, and 3 Fe, we want to find the mass, 56, the molar mass. The molar mass times the coefficient 3, we get, you put it into the calculator again, 56 times 3, you get 168 grams, 168. Now to find the limiting reactant, you do GR over RR. You do it for the iron, you get 5.6 over 168. You put it in the calculator, 5.6 over the answer. You get 1 over 30 or 0.033. Now you do it for the O2, 1.12 over 448.8. You get 1 over 40. Here the smaller ratio of GRRR is the limiting reagent. Here oxygen with 1 over 40 is smaller than 1 over 30. It is the limiting reactant. Now we know the limiting reactant and the excess reactant. The limiting reactant all gets burned up, and the excess reactant, not all of it gets used up. Here iron is the excess reactant, it doesn't get used up, not all of it. Not all of the iron will react. A solution in which the solvent is water is called an aqueous solution. You have to memorize this one. Is when you dissolve a solute into water, it becomes an aqueous solution because its solvent is water. You have to memorize it. 2 liters of 1 molarity NaCl solution is prepared in a flask. 400 milliliter of the solution is poured out of the flask into a beaker. What is the concentration of the salt solution in the beaker? Now we know that when you have a specific molarity, it doesn't matter the volume of it if it's from the same solution. Here they said 400 millimeter of the solution, of the solution that has 1 molarity. Same solution. Since it's same solution, the molarity stays the same and it's 1.0. How many moles of NaOH are present in 400 milliliter of a 2.0 molarity NaOH solution? We use again C equals N over V, and since it's millimeter, we convert it into liter by dividing by 1000. We get 0.4. For C, they gave it to us 2, concentration 2, and 0.4 for volume, and we want X the moles. 2 times 0.4 equals 0.8, and they want 3 significant figures. If you add 2 zeros to make it 3. In this question they want us to balance the equation, and it's here they gave us the Na plus and CO2 minus. Now in this question they gave it to us, we don't need to memorize it for this question, but in general you have to memorize it before the exam. There is this big table in the course questions, or in the book, yeah. There is this big table of what ions a specific molecule. In general, in the book, they give us this big table that we have to memorize. And now there is an easy way to memorize, to know some of them. It will be in my notes by tomorrow, in the periodic table way. But some ionic compounds like CO3, you have to memorize the charge of them. فهere we have Na2, Na2CO3, and it's put into water علشان solution is aqueous. Na2 plus Na plus CO3. CO3, normally we'd ignore the subscript until the end and we put it as a coefficient, but CO3, the 3 is part of it علشان it needs to bond. To get all of the valence electrons, it has to have 3 O. The 3 here is part of the ionic compound itself, but we don't remove it. And they gave us the charge plus CO3, and we go back to the subscript here, we turn it into a coefficient for the Na. Drag and drop in order to prepare 1 liter of 1 concentration of NaCl solution. Whenever you're preparing a solution or they want you to list the steps to prepare a solution, there is a math part وبعدين there is the lab or practical part. The math part here, they give us the concentration and they give us the volume. Here they want we want to get the N or moles. C is 1 and over equal x over 1. We cross multiply 1 times 1 equals x, and x is 1. We have 1 mole, and we get mass is moles times molar mass. Moles is 1 times molar mass, NaCl 23 plus 35.5. We get mass is 1 times 58.5, and because it's 1 it stays the same, weigh 58.5 grams of pure NaCl. And after we know how much grams of a solute we should add, we add a little bit of water, we swirl it, we create a concentrated solution at the bottom for the salt to dissolve fully. We add about 250 milliliters of distilled water in a volumetric flask. It has to be a volumetric flask. If it's in the written, you have to write volumetric flask. And it also has to be at the same exact volume that they give to us. And if they gave us 250 milliliters, for example, we need to put a 250 milliliter volumetric flask and swirl the mixture until until most of the salt is dissolved. And then we add more water until it fills the edge of the volumetric flask. There is one more step after this. You close the volumetric flask and then shake it to fully dissolve the solute. The molar concentration of a solution is the number of moles of solute per liter of solution. Now this is, you have to memorize the meaning of molar concentration. The molar concentration is when the molarity is... not when the molarity. Molar concentration is how many moles are in 1 liter. Sodium reacts vigorously with chlorine gas to produce sodium chloride as shown in the following chemical equation. In an experiment, 14.2 grams of chlorine reacted completely with a given sample of sodium. First thing, we check if the equation is balanced. We have 2Na and 2Na here, Cl2 and 2Cl2. The equation is balanced, we have an equal number of atoms. Find the number of moles of chlorine reacted. We have N is M over M. We have the mass is 14.2, and the molar mass of chlorine is 35.5. And they said chlorine gas, gases are diatomic, 2 times 35.5, you get 14.2 over 71, and you put it into your calculator. Over 71, you get 1 over 5, or 0.2, and they said you want 3 significant figures, so you add 2 more zeros in, for 0.200. Now for the next part, they said find the number of moles of sodium chloride produced. To find the number of moles of sodium chloride, we need to do RRGR. RRGR. In the RR we have 2 and 1, and sodium chloride 2. We have the given number of chlorine moles. Chlorine is 0.2, and they want the number of sodium chloride moles. You put x and then you cross multiply. X is 0.2 times 2, x is 0.4. And again they want 3 significant figures, you add 2 zeros, 0.400. Now they want the mass of sodium chloride produced. Sodium chloride NaCl. You multiply the molar mass by the coefficient. We have 0.4 moles of NaCl. Na is 23, Cl is 35.5 times 0.4, 0.4 times 58.5. You put it into your calculator. You get 23.4 grams. 3 significant figures. It's already 3 significant figures, so you put it as it is. If you realize this week is a lot of repeat from last week. A sample of 0.5 moles of butane gas undergoes complete combustion at RTP conditions according to the following chemical equation. 2CH4 H10 plus 13 O2 produces 8 CO2 plus 10 H2O. We again check if the equation is balanced. C4 for 2 for 8, yeah, 8C. H10 coefficient 2, 20, yeah, 10 times 2, 20. 13 O2, 26, 16 plus 10, 26. The equation is balanced. Find the number of moles of oxygen gas needed to react completely with 0.50 moles of butane gas. We do GR. In the reactant ratio, we have 2 moles of butane. As we said, RR is 2, and they want oxygen needed, we have 13. GR is 0.5 for butane, and X علشان we need to find it in O. We cross multiply. 2X equals 13 times 0.5. 2X equals 6.5, and then X is 6.5 divided by 2. X is 3.25. They want 3 significant figures. It's already 3 significant figures, so you put it as it is. For part B, they say find the volume of oxygen gas needed to react completely with 0.5 moles of butane gas at RTP conditions. We already got the moles for oxygen when it's 0.5 moles of butane. At RTP is 24 decimeter per mole. We have 3.25 moles times 24, and you put it into your calculator. 3.25 times 24, you get 78 decimeter cubed. They want 3 significant figures, you add 0.0. Air is 20% oxygen gas. Find the volume of air needed for the given sample of butane gas to react completely. As we said before, V air is equal to VO2 times 5. Now we have VO2 is 78.0 times 5. 78 times 5 is 390 decimeter cubed. 4.6 grams of sodium metal Na is dipped into excess water. An explosive reaction occurs producing an aqueous solution of sodium hydroxide NaOH and hydrogen gas H2. Give the chemical equation for the described reaction. So we have Na plus Na solid. They said it's metal, so it's solid. Plus H2O, excess water, liquid, gives Na NaHOOH aqueous solution AQ plus hydrogen gas H2. We need to balance the equation. We have one, as I said, we have one Na, 2 H, 1 O in the reactant side. Now in the product side, we have 1 Na, 1 O, 1 H, and another 2H. I like to put the plus in the middle to separate them. For now we start balancing. We leave hydrogen and oxygen to the end, oxygen till the end خالص, and hydrogen before oxygen. We start with Na, 1 Na here, 1 Na here, it's balanced. We go to hydrogen. We have 2 hydrogen here and 2 hydrogen here, and 1 and 2 hydrogen here, it's not balanced. We put 2 here, for now we have 2 here and a 2 here. Now we have 2 Na, 2O, 2H plus 2H. Here we have 1 Na, 4H and 2O. Now we go back. Now hydrogen is balanced. We go back to check if Na is balanced. Na here is not balanced. Na2 and Na1. We put another 2 here. Now Na is balanced. Now Na is balanced. We have 2 on both sides, and O is also 4 on both. 2 on both sides. Sorry. For now, we have our balanced equation. Also, don't forget state symbols, Sl, aqueous, and gas. Now, for the first part, find the number of moles of sodium metal reacted. We know the equation N equals M over M. N is the number of moles, M is mass, 4.6, and molar mass is 23. They gave it to us, and 4.6. If you put it into your calculator, 4.6 divided by 23, and it's 0.2. They want 2 significant figures, you add another 0 and you have 0.20. Now for part C, they are saying find the number of moles of hydrogen gas released. If we do RR GR, we have the number of sodium metal. For RR we have 2 here, and for hydrogen released we have 1, and for GR we have 0.2 here, and X for the hydrogen we cross multiply. 0.2 equals 2x. You divide both sides by 2, you get 0.1 equals x. And again you want 2 significant figures for 0.10. In this question, they want the steps used to separate the components of a mixture of sand and salt include the following. They also asked this question last week. First, you put some water to dissolve the sand and to dissolve the salt, and keep the sand insoluble. Then you filter it. You have the filtrate water in the bottom. It has water and salt, and the residue in the filter paper, it's sand. You then heat the filtrate and let it crystallize to form crystal salts, and you leave the residue sand to dry. You add excess water to the mixture and stir, filter and allow the residue to dry, and then heat the solution to crystallize. The liquid collected at the end of distillation is called the distillate. You have to memorize this one. Here they gave us the rate of diffusion of two gases, and they want us to choose the heavier gas. The rate of diffusion in centimeter cubed per minute. Gas X takes 1 minute to cover 0.63 of centimeters cubed, and hydrogen chloride takes 1 minute to cover 0.87 of centimeter cubed. Here hydrogen chloride diffuses faster, so it's the lighter gas, and gas X is the heavier gas علشان it diffuses slower. The heavier gas is gas X. Find the molecular mass of gas X. Here we use the law that we took is molar mass 1 over molar mass 2 equals to the square root of sorry it's rate of diffusion 1 rate diffusion 1, I'll just call it Y and Z, I guess, Y1 and Y2 over molar mass 2 you have the rate of diffusion 1 over rate of diffusion 2 equals square root of molar mass 2 over square root of molar mass 1. We can say Y1 مثلا is gas X, the rate of diffusion is 0.63 over the rate of diffusion of hydrogen chloride 0.87 equals the molar mass. Molar mass 2 is molar mass of hydrogen chloride. We have HCl 1H 1 plus Cl 36.5 square root of 36.5 and square root of X because we want the molar mass of gas X. You cross multiply 0.63 times the square root of X equals 0.87 times the square root of 36.5. You have this equation now and you want to solve it. 0.87 times radical 36.5, you get 5.256124999. Again, you never round in the middle of an in the middle of a question. You round at the end. If you have your calculator, you just press the answer button, and 0.63 radical X is equal to that number, and then you divide this answer by 0.63, you get radical X equals 8.3430555553, and then you square that answer to get rid of the radical. You get 69.60657596. Here in the question they wanted to 3 significant figures, so you get 69.6. For part 2, drag and drop the following to arrange them in increasing order of rate of diffusion. We have from the previous part, H is 1, Cl is 35.5. Here, as we said before, the more the molar mass, the heavier the gas is, the slower the rate of diffusion. Molar mass goes up, rate of diffusion goes down. We have CO2, we find the molar mass. C is 12. 12 plus 2, 16 is 12 plus 32, you get 44 for CO2. HCl, we got it from the last part, is 36.5. And H2O is 16 plus 2 times 1, you get 18. They wanted an increasing order of rate of diffusion. You have the heaviest one is CO2, then the second heaviest is HCl, then the lightest is H2O. That's the fastest to diffuse. وبعدين for part 3 they wanted the phenomenon responsible for two separate gases to collide with each other and react. That is diffusion, when the fumes or gases of different substances move randomly into the air and then collide with each other. And then choose the lighter gas. You have here the colored stain. You want the lighter gas, so that we know that the lighter gas will travel further than the heavier gas, and clearly gas A has traveled further than gas B. Gas A is the lightest one. And this is the quiz for section 2.8. This is the quiz for CA chapter 7, not chapter 7, week 7.